Hello everyone, my name is Buddha Bakar Muhammad. I'm going to walk you through a demo project that I recently implemented. The project is about remote state storage with S3 and DynamoDB. The goal of this project is to store uh, the Terraform state file remotely instead of locally to prevent multiple users from modifying the infrastructure at the same time. And it's a centralized state management, and it's also for a team collaboration. It's going to improve reliability and security. So I use Terraform to provision the entire infrastructure because Terraform reduce human error, ensure consistency, scalability, and security across the environment over manual provisioning using AWS console. So Terraform can allow a team can automate a complex deployment, track changes through version control, uh, and it has a lot of benefit, over provisioning the infrastructure using AWS console. So I'm going to briefly walk you through the networking infrastructure. So this is a VPC and with three subnet, uh, one public subnet, one private subnet, and one database subnet. And also I created variables, this is generic variables, and it's also good to practice to use variables and refer them. uh, you can refer to those variables. You see, that's gonna make our code cleaner and readable. And also I created variable for the entire uh, VPC component, like VPC name, variable VPC name, variable VPC CIDR block, VPC availability zone, public subnet, private subnet, for the entire networking infrastructure, and I refer them inside the model. So I use VPC, for example, name local that name hyphen var that VPC. So which is we combine the local, this one, this name, and then and also this name. What is it? Yeah, this name. So and CIDR block var that VPC. You see, it's gonna make all the code cleaner, nicer, and readable. So it's best practice to use variables. And this is the Terraform VPC auto var. So this is the we assign the actual value. So earlier we just gave the default value. Those are the actual value of our VPC name. This is the actual value, and VPC CIDR block, the value, and then the availability zone. So whatever those are, those when I write the Terraform apply, those values going to override all the default values. And yeah, basically this entire infrastructure is about three subnet and inside a two availability zone, which yeah, it's actually two public subnet and two private subnet and two database subnet inside two AZ. So this is the CIDR block of each subnet, the database subnet. This is the CIDR block of one subnet, and this is the second subnet for the database, and this is the private subnet, and this is the public subnet, which means we have six subnet of total. Of total. So it is recommended to use AWS console or AWS CLI to provision our S3 bucket and DynamoDB, because when we provision the S3 bucket in the same infrastructure, and you write Terraform destroy, so that's going to destroy everything, including the S3, which will contain our Terraform.tf state file. So that's why it's better to uh, provision the S3 bucket separately, not inside the Terraform. So I'm going to use AWS console to provision our S3 bucket in DynamoDB. So without further ado, I'm going to create the bucket. So let's go to S3. Yes, I forgot to explain this. And you see, this is the version we have where I have the back end of the S3 bucket. This is the Terraform block. It should be inside the Terraform the version. So backend S3, the bucket. This is the bucket name, the key. This is the path. The path where our Terraform.tf state should reside. The region will be US East 1. So now let's click create, and then the bucket name should be this one. Let's just copy demo. Okay, copy, paste it here, and let's enable also versioning. This is very important. Whenever you make change, so it's going to update a different version. So we leave everything the default and click create. So now that we created our bucket, so we can go ahead inside our bucket and create a folder called dev. So dev, and we leave everything default, create. Inside this dev, again, we need to create another folder called demo. Okay, demo VPC, demo-vpc, copy paste. Okay, and then so this here where our Terraform.tf state should be created when we run the Terraform apply. So now that we created everything, we can go ahead and create our DynamoDB table. So let's navigate to DynamoDB, and let's create table, and this should be the table name. So this is for state locking. This should be the table name. Okay, let's just copy. It has to be the same. Paste it. And one important thing also, we have to put the lock ID. This is very important to lock, which means, for example, when we create this DynamoDB table, will not allow two person to make change simultaneously. For example, if one team is trying to make some change inside our Terraform TV state, it is going to prevent another person to make change. So that's why it's called for state lock. It's going to lock. Then let's just create. So now that our DynamoDB table is created, we need to go run the Terraform command to initialize our plugin. So let's just open the terminal. We have to be in the same directory as all the folders. So let's see. So this is the directory where we have all the configuration file. Terraform init init. So it's successful, and we need to run the other command, Terraform valid. So we need to now run Terraform validate. So now it's valid, and then we need to run Terraform plan and apply. Okay, Terraform plan also is successful. We have 25 uh, resources to be added. You can write Terraform apply. Terraform apply. It's going to prompt us enter yes. So now Terraform apply complete, 25 resource added. We can go ahead and check our terraform.tf state file inside our S3 bucket. So our terraform.tf state files is successfully created as expected. So this is very good. This will allow a team, to collaborate, securely over like locally. So now we can go ahead and write Terraform destroy and see whether our S3 bucket, this file, this TF state file will be destroyed or not. So now that we have it successfully, we can run Terraform destroy. We can also check the other infrastructure. Let's quickly check the VPC, all the subnet component. So this is our VPC is already created, and let's check it. Let's go see the resource map. Okay, this is the resource map. We have 2 AZ, and then we have 2 public subnet and 2 private subnet, 2 database subnet. And you see the database subnet is not associated to the uh, to the uh, uh, to the networking. It's not like, for example, it's not connected to the internet. And our private subnet is associated to a private route table, or public subnet is associated to public route table. Okay, so now that we have it, let's go and check. So now we have to destroy the entire infrastructure and see. Let's write Terraform destroy. Okay, Terraform destroy auto approve, and let's wait until all the infrastructure will be destroyed, and then check our versioning in our TF state file. Okay, the 25 resource are successfully destroyed. So now we can go ahead, check our TF state file whether it's still there or not. We're also gonna check the versioning. So although we destroyed the entire infrastructure, we still have our Terraform TF state, which is successfully, demonstrated. And also, let's quickly check the version. Let's go inside. It also has different versions, so the versioning also is functioning, and this is successfully. I demonstrated the demo of implementing remote state storage with S3 and DynamoDB. Thank you for watching. I hope you liked the demo, and leave me some comment, please. Thank you so much.